Good morning, students. Here, chapter number 1, chemistry, class 9th, module number 4, which will be the last module for chapter number 1. That is matter in our surroundings, the chapter name. The topics that we are going to cover in this chapter, in this module, are interconversion between states of matter, sublimation, evaporation, factors affecting rate of evaporation. Let us understand the interconversion of the three states of matter. You can see this diagram, the representation. Here, this is the ice which is in solid form. When the heat energy is taken from environment, it starts melting and it converts into liquid. Again, still more heat energy is taken from environment and it converts in the form of evaporation and convert itself into a vapor or gaseous form. Reverse way, we can say, when heat energy is released or removed, or we can say we are lowering the temperature. Here the condensation is taking place and the particular vapor, the gaseous vapor like water vapor, condensed to form a liquid, which actually is the formation of rain. Here again, still more energy is removed or released to the environment. It freezes out to become again ice. This is an ice, water liquid and gaseous water vapor. All tells you about how this is happening. The other process is called as sublimation, where solid directly changes into the vapor form without undergoing into the liquid form. Okay, here again that is called sublimation. Reverse way, that is again the gaseous particle directly changing into the solid form, that is called as deposition or reverse way of sublimation. So this deposition means one by one the particle get deposited directly to form a solid without going into the liquid state. So this is your interconversion of the three states of matter. How does it work? This chart explains about the same. Now interconversion of the three states of matter in general. Here you can see the triangular structure, the interconversion between solid to liquid, liquid to gas, and even solid to gas, as well as the reverse way of each interconversion. Solid changing into liquid is called fusion. But when you talk about the reverse way, liquid again getting condensed, or when it cools down, it solidifies. The process is called as solidification. Again, the same way liquid can also get converted into gaseous form, that is called as vaporization or evaporation, which is taking more energy from the environment and converting into the gaseous vapor. Again, in the reverse way, we can say when again it is cooled down or energy is given to the environment, the gaseous particle again condense to form a liquid, which is again a reverse way. Same way, solid directly goes to the gaseous form without going to the liquid state. The process is called sublimation. For example, ammonium chloride, iodine, then camphor, these all are the example of sublimation. These all are the sublimating substances, solid changing into the gaseous form, called sublimation. The reverse way is the particles get deposited one by one to form again the solid, that is called as deposition or the reverse way of sublimation. So hope you understood this interconversion between the states of matter for all solid, liquid and gaseous. Here the process called as sublimation of ammonium chloride. We have taken here the gas burner, Bunsen burner. This is a funnel. This is china dish, and we have taken ammonium chloride, which is white in color. Cotton plug is used to avoid the escape of the gaseous vapor of ammonium chloride, and it is heated. Once it is heated, the particular vapor which is formed again get condensed to the wall of the particular funnel and indicates that gaseous form and the solid form are the interconversion in the process of sublimation. Sublimation, the process in which a solid changes into vapor without changing into liquid and from vapor changes into solid without changing into liquid is known as sublimation. Generally, solid first changes into liquid and then changes into gas, as we know, because of rise in temperature. But there are many substances which change into gas without changing into liquid and changes into solid from gas without changing into liquid. Such substances which go under sublimation are known as sublime. For example, camphor, naphthalene ball, ammonium chloride, iodine, dry ice, which is all called as solid carbon dioxide, etc. The solid obtained after cooling of the gas of sublime is called sublimate. The process of cooling of vapor of sublime to get sublimate is known as sublimation, although it is also known as deposition. When camphor is heated, it changes it into vapor without changing into liquid. When the vapor of camphor is cooled, it changes into solid without changing into liquid, and hence this all signifies the process of sublimation. Let us understand the topic called as evaporation. What is evaporation? It is very different from vaporization, because vaporization occurs at its boiling point. Any liquid which converts from liquid to the vapor form or gaseous form or at its boiling point is called vaporization. But here evaporation is different process. Evaporation is it occurs the temperature below its boiling point, means at any temperature the evaporation can occur. The process of liquid changing into gaseous vapor at the temperature below its boiling point is called evaporation. And evaporation here also is a surface phenomena. It starts evaporating from the surface by taking heat or the energy from the environment. But in other case, vaporization, it is a bulk phenomena. After the whole liquid is getting the equal temperature, after it reaches its boiling point, then it starts forming into gaseous vapor. Factors, there are 5 factors that affects the rate of evaporation. That is, these are the factors that affects the rate of evaporation. First one is temperature. Temperature, when you increase the temperature, definitely due to increase in temperature, more kinetic energy will be processed by the liquid particles and it will be converted into a gaseous vapor. Definitely more the temperature, more will be the rate of evaporation. Hence the increase in temperature increases the rate of evaporation. That means temperature is directly proportional to the rate of evaporation. Next we have surface area. Here evaporation increases with increase in surface area and decreases with decrease in surface area. For example, when you talk about cup and saucer, people used to pour the tea in saucer so that the liquid should have more surface area and tea gets cools down to sip it very comfortably. Okay, so that's why more surface area, more the rate of evaporation. Lesser the surface area, definitely the less the rate of evaporation. Here again the surface area is also directly proportional to the rate of evaporation. More the surface area, more will be the rate of evaporation, and vice versa. Talking about humidity, humidity is the amount of moisture in air. Hence, when already the more moisture, more water vapor is present in atmosphere, definitely the rate of evaporation will decrease. Here the humidity is inversely proportional to the rate of evaporation, because when already there is a water vapor in the atmosphere, the tendency to evaporize or to evaporate will become lesser. That's why during the rainy season you may find it is very difficult for the clothes to get dry easily, because of more moisture already it is present in the atmosphere, and again taking more vapors from the cloth is quite difficult. Hence we use electric heaters and all for drying the cloth. So that here the humidity is inversely proportional to the rate of evaporation. Means increasing humidity decreases the rate of evaporation. Wind speed. Here again, more the wind speed, definitely traveling in the vehicle, if you keep few drops of water, just you will find that water evaporates at the faster rate rather than you stay at one place. So definitely when you increase the wind or the air speed, definitely the rate of evaporation will be faster. That means the faster the wind speed, more will be the rate of evaporation. That's why we on the fan during the rainy season, when we keep the cloth inside for drying in the living room or whatever it may be. Wind speed is directly proportional to the rate of evaporation. More the wind speed, more will be the rate of evaporation, and vice versa. So these all were the factors affecting the rate of evaporation. Practice work 4. Practice work 1, 2, 3 from module number 1, 2, 3. I hope everybody would have submitted on Google Classroom. Now this is practice work 4. What is common among the three states of matter? Why does a gas fill a vessel completely? Why evaporation is called surface phenomenon? Explain why ice has lower density than water. Complete this. Discuss with me if you have any doubt. Here we have ended with chapter number 1. Thank you all of you.